Welcome back to Calculus with Mr. Robeson. Today we're going to learn some more rules for taking integrals. So we're going to look at specifically log rules, do some examples, and then we're going to look at how to do long division. All right, so log rules. So we know the derivative of the natural log of something is just 1 over that something, or 1 over x. Or if there's something inside, it's the derivative of the inside over the inside. So that means if we have something like this or something like this, and we take the integral of it, that will just bring us back to what we had in here. And don't forget to add a plus c. So there's our integral rule. The integral of 1 over x dx is the natural log of the absolute value. Don't forget the absolute value of x plus c. And the integral of, if we have the derivative of something over that something, it's the natural log of that something that was on the bottom, absolute value of that, plus c. So here, an example, like the 2 can come out front, and this would be 2 times the integral of 1 over x dx. So that'd be 2 times the natural log of the absolute value of x plus c. All right, over here, a little more work. So anytime we have a linear function on the bottom, this is going to work. We set u equal to the bottom. We take our derivative. Here's our dx. So we need a 4 on top, so we just put times 4. We got to cancel it out, so we put a 1/4 out front. So now all this becomes our du, and this bottom thing here is our u. So we've got 1/4 the integral of du over u. It has to be on top, or 1 over u times du. It's got to be in this form. We can't have du on the bottom. That never works for us. So we get 1/4 the natural log of the absolute value of u plus c, and then we plug back in for u. So we get 1/4 the natural log, the absolute value of 4x minus 1 plus c, like that. Sometimes we bring the 1/4 in as an exponent. We can say it's the 4th root of that. All right, so some more difficult examples. Again, trying to recognize this. So whenever we have trig functions, there's lots of things we could do with trig identities and things like that. But let's just try and set the bottom equal to u. If we have a fraction, always try the bottom equal to u, because that's what we have here. The bottom is u. So if we say u equals tangent of x, then the derivative of tangent is secant squared dx. So here is our du right there. So we've got the integral of du over u. So we get the natural log of the absolute value of u plus c, and then we plug back in our tangent. Natural log of the absolute value of tangent plus c. It is important to have those absolute value bars, guys, so don't forget to have those. Next one, again, we've got a fraction here. The power on the degree on top is 1. The degree on the bottom is 1 bigger than that. So it makes me think if we take the derivative of this, we might end up with something close to that. So we're going to set u equal to the bottom. So then our derivative will be 2x plus 2, all that times dx. All right, well, that doesn't look like 2x plus 2, but I can factor out a 2 here. And then we realize, well, hey, if we just take this x plus 1 and multiply it by 2, now it matches. So we'll put a 1/2 out front to cancel it out. So now all of this top part here becomes our du, and this bottom part here is our u. So we get 1/2 the integral of du over u, or 1/2 the natural log of the absolute value of u plus c. So that is 1/2 the natural log of the absolute value of x squared plus 2x plus c. And if we want to we could bring this 1/2 in and say that's the square root of all that, or all this raised to the 1/2. That works too. Again, lots of things we can do with log simplifications. Next one. Again, the power on the bottom is 1. The degree on the top is 0. So the degree of the top is 1 less than the degree of the bottom. Or we can just say, hey, the bottom is a linear term. This is always going to work in a natural log if the top is a constant. So then du equals 3 dx. So we need a 3 up here. We cancel it with the 1/3. So we get 1/3 the integral of du over u, because all this part here was just our du, and this down here is our u. So we get 1/3 the natural log of the absolute value of u plus c, or 1/3 the natural log of the absolute value of 3x plus 2 plus c. And there's our answer. All right, not so bad, right? I hope. All right, we can again continue to do this with definite integrals and finding area and that sort of stuff. So find the area of the region bounded by the graph of this guy, the x-axis, and the line x equals 3. So we had a homework problem like this the other day. So the line x equals 3 goes straight up from here. This is our y equals, so this is the curve. This is our x-axis down here. And the other point we get is where the graph crosses the x-axis at 0. So the way we find this area is the integral going from 0 to 3, so from 0 to 3, of x over x squared plus 1 dx. All right, so now I'm going to try and do my substitution because the bottom is 1 degree higher than the top. I'm going to try and say u equal to the bottom. Notice I've never said u is the top. It's always the bottom. So du equals 2x dx. So we've got an x, a dx, we need a 2. We'll put a 1/2 out front. So now we've got 1/2 the integral. I'm going to leave off the bounds for now because I've changed variables. So du over u. So this is 1/2 the natural log of the absolute value of u plus c, or 1/2 the natural log of the absolute value of x squared plus 1. And now that I've gone back to x's, now I can go back to my bounds. So I'm going to go from 0 to 3, which means I'm going to plug in 3. So we get 9 plus 1 in there, minus plug in 0. All right, so this is 1/2 the natural log of 10. Don't need absolute value anymore. The natural log of 1 is just 0, right? Because e to the 0 equals 1. So the natural log, 0. Natural log of 1 is just 0, so this is just 0. So we just get 1/2 the natural log of 10, or we can say this is the natural log of the square root of 10. Either one of those is okay. All right, so that is this area. All right, long division. So if we're looking at this and the power or the degree on top is the same or greater than, so is greater than or equal to the degree on the denominator, the bottom, then we can use long division to simplify. All right, so long division means we're going to take this bottom guy and divide it into this top guy. So now when we do long division is we try and make this always match the first term here. So to make those match, we just have to multiply by 1. So 1 times x squared is x squared. 1 times x is, 1 times 1 is 1. And then we subtract this whole thing here. So these are going to cancel. We bring down this x. 1 minus 1 gives us 0. So we just get x. And once this guy has a smaller degree than this guy, we stop. And we put this over that as our remainder. X over x squared plus 1, like that. So this integral is exactly equal to the integral of 1 plus x over x squared plus 1 dx, like that. All right, we can separate this into two separate integrals. The first one will be just 1 dx. The second one will be x over x squared plus 1 dx. This one's nice and simple. It just gives us x, or x plus c if we want. This one, we're going to do some substitution. So we're going to say u is the bottom. So, and most times when we do these long division ones, we do end up with some sort of natural long term and using the u substitution. So du is 2x dx. We've got an x, we've got a dx, we need a 2. So we put a 2, we cancel it with a 1/2. So we've got 1/2 the integral of du over u, which gives us 1/2 the natural log of the absolute value of u plus c. And then we go back to this. All right, x squared plus 1 is always greater than 0. So we don't really need the absolute value bars there. So this just becomes 1/2 the natural log of x squared plus 1 plus c. And if we want, we can bring the square root in and say this is the natural log of the square root of x squared plus 1 plus c. Now don't forget we also had this guy here. So our final answer is going to be x plus this guy, ln of the square root of x squared plus 1 plus c. So we just put our two answers together, and there we go. That's long division. All right, so there's some basic log rules and long division with a couple of examples.